Hello, welcome to CS101, Introduction to Computer Science. This is class 3 and we're going to be talking about software today. Alright, so let's start talking about what software is. Software runs on top of computer hardware. It's basically soft in that it's a software program that's malleable compared to hardware, which is hard and already set in stone in the sense that you can't change hardware too much, and software is more malleable and it can be constructed and formed by code. So to put it simply, software is stored in data along with storage. It's stored in the hard disk or flash drive. It's loaded into memory, RAM, which we talked about in the last class, and it's processed by the processor when executed. So the software is loaded in memory and the hardware runs it, and it reads in data either from the user or other sources. It can read from the file system or other parts of memory, and it writes back the data to the screen or other sources. So we already talked about files that live on the disk and in memory, and we talked about the hardware which processes it, and software is kind of the intelligence that tells the hardware. It gives it the instructions on how to do things and what to do, right? So how is software coded? The idea is that you code software using a programming language like Java or C or a whole bunch of other language options these days. So it's basically a high-level language. It's what is called a high-level language. It's close to human language, not exactly the same, but the logical constructs are similar to human language. And then there's something called a compiler, which converts that language that you write in a human-readable language into machine code in bits and bytes that the computer can understand and execute. There's also things called interpreters, but we won't talk about that. But the idea is that you write a program in a high-level language which is close to human language, and a program called a compiler takes that and compiles that into the machine code, which is run on the device, the hardware itself. Let's talk a little bit about C and C++. We won't be covering that in this course actually, but that was the first true high-level programming language. Before that, people used to write programs in assembly, which was very hard to write. And for example, you would write code in assembly to move data from one location to another. In C, you basically assign variables to each other, and it makes it much simpler. It was developed at Bell Labs in the late 60s, early 70s, and C++ is a follow-up which introduced paradigms such as object-oriented software and classes, which are still very popular today in other programming languages. That was developed in the late 70s also at Bell Labs. And just to give an example of what people used to wrestle with in the early days of computers. So at the top right, you see an image which is how people used to code in assembly language. That is the exact set of instructions that are executed by the computer processor, and you tell it to move data from one memory location to another or do things like increment a stack variable. And a program called an assembler converts this code into bits and bytes. But there's an exact one-to-one mapping between what a programmer writes and what the computer executes. Now, if you look at that code right at the top right, you will notice that it's a little difficult to find out what that program is doing. Actually, what it's doing is printing hello world, but you can't tell it because all you can see is it's moving data from one place to another, and you don't know what it's doing. At the bottom right, the image at the bottom right of the slide is the same program written in the C language, and as you can tell, it's still complicated, but it's kind of closer to English language. The first 3 lines are comments, and then there's other stuff, but notice the third line from the last, which is printf hello world. All it's saying is print the statement called hello world and exit. So it's a bit closer to human language than the assembly language that you see above. This is compiled to a machine language, which you see above, using a compiler and into bits and bytes. But end of the day, you won't have to worry about writing code in machine language. With the high-level language, you focus on writing your logic in an English-like syntax, and the compiler takes care of that for you. So how do you write software, right? So it's basically, how do you think about solving a real-world problem? So let's use a real-world example to give examples of how you write software. Say you have a printed phone book with names sorted in alphabetical order. For those of you who have never seen a phone book or a phone directory, it looks something like this on the right. There's a big book with lists of people's names in alphabetical order, and the idea is you go through the book and you look up an index. It's in alphabetical order, so you find the person by looking for the name and get the phone number. So the problem you have is to find someone's name, right? How would you go about it? So let's think about how to do this as a human first, right? And then we can apply that logic to computers. So let's think about this, and we'll write this also in what's known as pseudocode, which is not really programming language code, but in a human readable format. So one solution is to start from the very beginning. Let's say you're looking for someone's name like Sam in the phone book. You start from the very beginning, start from page 1, check all the names on the page. If the name is on that page, turn the page, go to step 2. Now, this is a great solution. It'll work, but the only problem is you have to keep scanning page after page and, to get to the name. And given that Sam, S, is, at the end of the alphabetical order, it's going to take you some time to get to the name. But we know that the book is sorted in alphabetical order. So what does that tell us? So S should come closer to the end of the book, right? So one other solution we can do it is to open the book to any random page. Open a random page in the book, maybe the middle page, right? Let's open the book to the middle, and then you can look for the name on that page. Now, we know it's sorted in alphabetical order, so let's say the name is not on that page. If the name is before this page, then you open a random previous page. Now, it doesn't have to be random again. You can open the middle of the section just before that page that you're on. Or if the name is after this, you open a subsequent random page, and it could be, in the middle of, the end of the book, right? So that's how you would quickly sort through any data that's organized in a meaningful fashion. So we can apply this exact same thing to software programming. So let's actually look at how this process of searching for someone's name in a phone book would look in a real programming language. So in a computer program, you just take what you wrote in English in the previous page, those steps, and you write it in your favorite programming language. That's it. But of course, you do need to have a basic understanding of programming in those languages. So the next few slides, we'll see what that logic that we wrote looks like in 4 different languages in Java, C, JavaScript, and Python. So this is what that looks like in Java. By the way, the code that we just wrote is a version of a search called binary search. Don't worry about the semantics at this point, but the idea is that on the first line, you're defining a function which is called binary search, and it takes in 4 parameters, which is an integer, list of integers, which is numbers. There is an integer you're searching for, and then there is a low point and a high point, which is the range that you're searching for. Now, the second line basically is an invalid condition. Low should never be high. So if you get to that point, you want to return failure, which in this case is -1. Line 3, so you have not, you're looking at the middle. So you want to sum up low and high and divide by 2. Basically, the idea is that, given a low range and a high range, you want to find a place in the middle. So you add those two numbers up and divide by 2, you get to the middle point. Line 4, if the middle point is the number, right? If A is the list of numbers and X is the number you're searching for, and the middle of that range that you're searching for is that number, you return that middle point. That's where the number is, and that's where it can be found. Now, if that is not the case, you basically, in line number 5, you're checking if the number that you just found is less than the number you're searching for. If that is the case, you want to actually run this exact function again, except you pass in the low number as that middle point, that page you're on, +1, which is the next page, and you still keep the same high range. Whereas if the number you found is greater than X, which is the else statement in number 7, you run the same search, but now you're going to the previous half of that list of numbers. So you pass in A and X and the low range, and you keep the low number as it is, and to the mid -1 is the previous page that you're looking for. So this is something called a recursive search, a recursive function. You don't need to worry about it, but the idea is that this is in Java. It's the same thing as what we described in human language before. You flip open a page in the book, and if if it's less than the number, you go to the right of the book, and if it's greater than the number or the name, you go to the left of the book, right? Let's look at what this looks like in C. So you can see here that the line number 3 in this page looks almost exactly like the one in Java. And 4, 5, 6, checking if low is greater than high. In line number 9, we check for the middle point. In line number 10, if it's not the one, we don't find the key, we return that. And in lines 11 to 15, it basically does the exact same thing that we did previously, right? There's some small differences, but more or less the same as Java. Let's look at what this looks like in JavaScript. Line number 1, we're defining a function called binary search, passing in an array and one integer. Notice that this has 2 input parameters rather than 4. And line number 2, same thing, calculate the midpoint. Line numbers 3 and 4, if that number you're looking for is the midpoint, return that. Otherwise, in lines 5 to 8, notice here that there's something slightly different going on here. The idea is that instead of passing in a low and high range, in this JavaScript function, you're passing in half the variables. So the line number 6 and 8, you can see aar.splice. What's happening is that it's simply taking the subset of the array and then passing that as the parameter to the function. But the idea, again, is more or less the same. In Python, this is slightly different, but not too much. Again, first line is the function definition, def instead of function or some other string. Binary search, again, you see the value being searched for, items, low, high. And then it does a check for, in lines 2 to 3, lines 2 to 5, it does a check whether that is the item it's searching for, and otherwise it goes in and it does a binary search in lines 10 to 14. It basically checks if it's less than the value, it goes to the previous half. If it's greater than the value, then it goes to the next half, and ultimately it's doing the exact same sort of search. Now, I don't expect you to have fully understood what we just talked about, like all the code and things like that. Again, we'll talk a little bit about programming language concepts, but the idea that I want to emphasize here is that whether you coded in C or Java or JavaScript or Python, the code was almost exactly the same, especially for C, Java, and JavaScript. There's a few differences in Python. Again, the structure and syntax was slightly different, and you will understand more about those programming languages when you go over them, but the code itself was more or less the same. Which is why nowadays it's actually a lot less about the language and more about the work that needs to get done, what needs to be programmed. Most of the smaller companies and startups will actually use a programming language that's easier, like PHP or Python, rather than the traditional safe languages to use, especially for web applications and websites. So again, different tools for different purposes. C++, and Java used to be the token answers for programming all sorts of applications. Today, there's no longer a one language fits all. For web applications, you use HTML, CSS, and JavaScript, and Java, Python, PHP, or Ruby are used for server-side applications. You use Objective-C, Swift, Java, or more recently Kotlin for mobile app development, or Python for statistical analysis. And a future job might require you to use any programming language. So if you understand the basics of programming languages taught in the course, you should be able to pick up other languages easily. So if you learn Java or Python, at least you understand the fundamentals, and you should be able to transition to other languages that you need.